each interface of ASA must be configured with security level. So you can say whenever I'm going to configure my inside interface, okay, so I should configure here security level. So security level is like 100, right? And whenever I'm going to configure outside, so outside interface must be with another security number, okay, like security level 0, or it can be anything. So Cisco Firewall or Cisco ASA sends traffic by default on the behalf of security level. So that means if any traffic is going from higher security level to lower security level, so that will be pass easily. So there will be no restriction, okay. So that means if firewall is sending data from higher security level to lower security level, that means LAN have higher security level 100 and WAN interface have security level 0. So that means this traffic can be forwarded easily. But when traffic is from guys lower to higher, then it will be dropped. It will be dropped, guys. So now in this picture, can anyone explain me why the traffic is dropped in this case? So I have same diagram here. Okay. Now, so what I'm going to do, this interface have here security level 100, okay, and here this have security level 0, right? So anyone have idea why the traffic is dropping when traffic is coming from higher to lower, like traffic is coming from outside network to inside? So on this WAN interface we have security level 0, so 0 is the lowest security level, and LAN interface have security level 100. So when traffic is trying from lower to higher security level, ASA will drop it. So what is the reason? So I want to know the reason here. So I hope everyone remember the reason. We discussed in detail about that.
TCP and UDP packet will be allowed by default, and
Um,
IP packet will be dropped.
okay, yeah, that is another case. But suppose traffic is initiated from WAN network, not from the LAN network. So just forget about this. Okay, don't think about this. Okay, so just say traffic is coming from outside network and trying to come in your LAN network. So like the traffic is not from LAN to WAN first. So just initiator is on WAN network, or you can say any attacker, you can say, or any user. So this is a normal user who initiated the traffic. So this is initiator, okay. So initiator is sending data on WAN port, and now why firewall will drop it? So this is the question.
First of all,
So
if
if
there
you
is
remember,
a connection table,
mhm,
there is no if there is no entry for the connection table, it will check the service level. Is it going?
okay,
It is going from lower service level to higher, then it will drop by default.
okay. Let me repeat my point. You are right. So this is the firewall, right? So again, I'm using, okay. If you have any question, right? Deny rule from untrusted to trusted. Right, Shiva, you are correct. So suppose this is the firewall and I'm using again multiple interfaces. Okay, you have to understand this point, guys. Okay, we are not in any hurry. If you understand this point, you will understand the complete behavior of ASA with any feature like NAT, ACL, or in VPN. Okay, so just suppose every interface have security level. So this have 100 and this have 70 security level and this
This is
have
20.
50. Yeah, yes, Kennel. This have 30, right? So we mention multiple security levels. So now there is a rule on ASA. If any traffic is coming from higher to lower, that will be pass. So traffic is allowed from higher to, just a minute. Okay, higher to lower. So there is no problem. So this will be accepted.
Pass.
Okay, okay, and lower to higher will deny.
Deny.
By default, if traffic is coming from higher to lower, that will be deny. But let me tell you why. Before that, I told you each interface have security level policy, right? So according to security level policy, like this interface also have its SLP, security level policy, and this interface also have SLP, right? And this interface also have SLP, but this interface don't have. Okay, which interface is with lowest security level that don't have SLP? SLP is actually a rule, or like defining the criteria where traffic can be forwarded. So that, for an example, if traffic is coming on this interface, okay, on firewall, on this interface, and firewall want to send the traffic on another interface which have lowest SLP, so traffic will allowed. So there is small packet flow in this case. So in first step, firewall is receiving traffic on this interface, right? So firewall always check the destination, and according to destination, firewall check the routing table, right? Am I right, guys? So routing table always gives you idea where you have to send the data, because routing table tells you about exit interface. Am I right? So once firewall know the exit interface, firewall check the
Security level.
security, yeah, security level policy, right? So security level policy tells like from higher to lower you can send. So firewall check, okay, traffic is sending from policy level
Higher.
100 to, yeah, higher to lower 70. So this must be allowed. So this must be allowed, right? Normal. And for that, as we know, ASA is creating a table. I'm telling you, let me tell you later about that, guys. So just I'm trying to explain you how ASA is working here. Okay. So traffic is coming on higher security level. Firewall check the security level policy. Security level policy means if traffic is from higher to lower, we will accept it and forward it. So traffic is coming on this interface, okay, and sent to another interface peacefully. There is no problem. Okay. Similar, it can forward traffic for like from this interface to this interface without any problem, and here also, right? So there is no problem. But if I'm saying here, if traffic is originated from this interface with SL which have SLP 50, so traffic is going to send from this interface to this interface, right? So at that point, firewall again check the routing table, okay, and according to routing table, traffic must forward to this interface. But according to security level policy, because this interface also have SLP, and traffic will be denied on this interface. Why? Because from lower security level you can't forward to higher security level. So this is the rule of Cisco ASA, right? And now this is for which interface have SLP. Okay, so if any interface have SLP and that interface try to send data to another interface which have higher SLP, so traffic will directly drop on the interface because of service level policy, because of service level policy. But again, we have one question here. This interface don't have SLP. The first reason, this is the lowest security level interface. Okay, If this interface don't have SLP and traffic is trying to forward from this interface to again any other interface which have higher security level, so how device will deny the traffic here because this interface don't have SLP. So on interface level, firewall cannot drop the traffic. And as you remember, I told you firewall have here one global policy. Firewall have here one global policy. And what is the global policy, guys? Global policy is deny any, right? So that means if any interface don't have policy, like for an example, this interface, if there is no policy, it will send data to this global policy, and global policy is saying you have to deny the traffic. So that traffic will be denied here. That traffic will be denied here. Are you getting my point? Daniel, Kenel, Siva, Mandita, sorry, Nandita, guys.
Yes, sir.
Okay. Daniel, do you have any question?
No, it seems clear.
Okay. Now, so I'm again coming with my same diagram, right? So this time, just I'm trying to explain you. Traffic is initiated from LAN network now. Okay. So it will send from higher security level 100 to lower security level 0. ASA will send that data, okay, through it. And now server have to respond. Server have to respond. So server is sending a response packet like this. So again, traffic is on security level 0 and trying to send on security level 100. So as we know, ASA must deny that traffic. Are you getting my point? So, but this is a problem. This is problem. Why this is problem? Traffic is initiated from a trusted network. So we won't reply for that traffic. We won't reply for that traffic, right? We don't want to manually approve this traffic. Why? Because if this behavior is going on with ASA, so what we need to do on this interface when traffic is returning to ASA from outside to LAN, because we send from LAN to WAN, that will be allowed because of security levels. But same, the response of the traffic will come to ASA on the same outside interface, and ASA will drop it. So what is the first option? The first option, I can configure here one security policy by myself. Okay, if this traffic is coming, you must allow, like I can match this is ICMP traffic, you have to allow. But I can't match specific traffic according to port number. Maybe this is some TCP traffic. So as we know, source port is here always random, like 1026. Okay, so my PC can generate any random port number as I know. So that random port I have to approve on WAN interface, right? On WAN interface. So this is not possible for me, or it will create a huge policies, right? So again, the configuration, or maybe by mistake, I will approve some ports that can make challenge for me in future, right? So that's why ASA have here inspection engine. What ASA have? Inspection engine, guys. So ASA inspect two type of traffic, TCP and UDP, but not IP traffic. Okay, are you getting my point? So ASA have here one inspection engine. So this inspection engine says whenever any traffic is initiated, that sends through the ASA and approved according to the security levels. So ASA must maintain that traffic entry in a table. And what is the name of the table, guys?
Stateful packet inspection.
Yeah, that is stateful packet inspection, but that entry contains inside your connection table. That entry contains inside your connection table. So that means if I have, okay, this diagram, wait a minute. Okay, for an example, we have this diagram again. Okay, so the user is initiating here some TCP traffic. Okay, so this is some TCP traffic. So for an example, source port number is 1024, okay, and destination is like 23 if there is some telnet data, and the source IP is 10.1, okay, and destination IP is 12.2, the server IP. So this traffic is sent by the PC to firewall. So this is ASA device, okay. Now whenever ASA is coming, so now we can say when ASA is receiving any traffic, so first of all ASA check connection table, count table, you can say count table, connection table, because if traffic is for first time, so there will be no entry in connection table. But if traffic is not for the first time, then there must be entry in connection table, okay. And after that, if there is no entry in connection table, it must check the routing table, okay. And after routing table, firewall check the security level policies of interface, and then create the entry in count table into connection table, okay. So that means, for an example, traffic is for the first time, so the client is sending traffic for the first time to the ASA. So ASA will check, first of all, okay, is there any entry from this source IP, this destination IP, with this source port number, with this destination number. So there will be no entry in connection table on firewall. So at that time, firewall must check the routing table first, okay. So it will check the routing table, like where I have to forward this traffic. So router will check, okay, destination is 12.1, so I have to put on this interface, okay. And before that, firewall check, I need to check the security level policy. So here uh, security is here 100, service level security, and here is 0, okay. So firewall say, okay, it's from higher to lower, so I can easily forward the traffic. I can easily forward the traffic. So traffic will forward from higher to lower, okay, after checking the SLP. And once traffic will forward on this interface and traffic is about to leave the device, so at the same moment ASA is going to create entry into count table, into guys count table. So count table will create like this entry 10.1 with port number. This is the port number, okay, trying to send data to 12.2 to on port number 23. So it's IP address, and after colon this is your port number at transport layer, destination IP and destination port number, right. So this will be the entry, and even it will show you the protocol, which protocol are you using, TCP or UDP. So once this connection table created entry, traffic will forward to the destination device, okay. And now destination device is going to revert, like if you are sending TCP packet, like this is your synchronization packet in TCP 3-way handshake, server will send which packet, guys? You must know the TCP 3-way handshake. So this is SYN packet, and the server will send here SYN plus acknowledgement, okay. I hope everyone knows that. So this time traffic is coming on the same interface again, but this time ASA is going to check first which table, guys? Connection table, because this is the packet flow of ASA. First check the connection table. If entries exist in connection table, just pass the traffic checking the connection table. No need to check routing table, no need to check SLP, right? Because entry is already there. But if there is no entry, then you need to check routing table, SLP, right? And according to you to decide, you can allow or deny the traffic. But this time, if ASA check the table, so entries exist here, because now source IP is, what is the source IP, guys? 12.2, and port number is 23, right? And sending to 10.1 to port number this one, right? Right? And they are using TCP. So this is data in your packet. So this data match with the connection table. Doesn't matter who is source, who is destination, because this is the entry. So there will be always opposite data. Like if source is 10.1 in connection table, so at the time of reply, source will be 12.2, which is in destination here, right? So now ASA check the connection table and just pass the traffic directly to the LAN. So now there will be no drop. So this is stateful packet inspection. This is stateful packet inspection. Are you getting my point? the behavior of Cisco ASA. Is this concept clear to everyone?
Mm-hmm.
Okay, if you know this
Yes.
behavior, if you know this behavior, you will understand that today's practical. Otherwise, you will not understand anything else except the commands, guys. So just feel free to ask, please. Okay. Okay. So this is idea about Cisco firewall. Okay, the traffic and all. So I told you, Cisco ASA inspect two type of traffic, TCP and UDP, but not the IP traffic, because by default IP traffic don't have port number, so Cisco ASA can't inspect that. So we need to inspect it manually. What do we need to do? We need to inspect ICMP traffic manually. By default, that traffic denied. By default, that traffic denied. How? Let me explain you. So suppose the 10.1 is trying to ping to your 12.2. Okay. So at that time, 10.1 is going to send ICMP echo request packet, right? And the source IP is 10.1 and destination is 12.2, right? So traffic will come to ASA. So when ASA is receiving the traffic on this LAN interface, ASA is going to check connection table. So there is no entry for the first time. Still, it will create entry in connection table because this is the default behavior of ASA. So what it is going to do, it's going to create here entry in connection table like that. Count table 10.1 with port number 0. So it will use a port number 0 because the traffic belongs to layer 3, not from layer 4. Destination is also 0, right? And protocol is ICMP. That means traffic belongs to ICMP. Okay. So once traffic is forwarded from ASA and connection table have now entry, you can say entry will be there. So now firewall sending data to server. Server will respond this time. But when traffic is coming on this interface, ASA is not going to check connection table. Why? Because by default ASA don't inspect ICMP data, or you can say IP data. So what will be behavior here? Anyone? I explained it already in last class. So if
It will drop the packet.
yeah, it will drop the packet, but how? Like traffic will come on WAN interface, right? So first of all, it will not check the connection table. Okay. So connection table will not check here. Why? Because of ICMP traffic. It
It
will
will check
check.
the routing table
Yeah,
first.
it will check the routing table, right? So routing table gives you idea about exit interface, which is LAN. Okay. And now it will get idea. I have to send to
SL.
LAN, and even it will not check the SLP. Why? Because the interface is already with the lower security level. So lower security level don't have SLP because the WAN interface is with 0 security level and the LAN is with 100. So which is with lowest security level number that don't have SLP, security level policy. So traffic will hand over to firewall, and firewall check the global policy, right? Okay, so it will check the global policy. And what is the global policy, guys? Deny IP, deny IP, any. So that means traffic will come to deny IP any here, right? So that means traffic will come to ASA and it will be denied here. So what we need to do in this case? Any idea? Okay, so that we will see in today's practical. If this is clear, so I can start with the practical, guys. Guys, any doubt till now?
No, sir.
Okay, cool. So let me share my screen. So I think this is visible to everyone, right? Uh, okay. Now we have here R1, firewall and R2. So let me place here one more router. So what I need to do, I need to stop my all the nodes first. Okay. So LAN have here network of 10. Okay. Hmm. So what I want to do, I can place here one switch. So I need IOL device and the image is L2, L2 for switch, L3 for router, and we can give a name here, switch one. Wait a minute, I forgot to change the icon. It's router, so we need here one switch. Where is layer to switch? Okay, so this is our switch. So just move to wire and delete it. And we need one more router here. It's layer 3 miss. The name is R2. Okay, it's gig 0 by 0 on LAN side, and WAN have gig 0 by 1, and let's make it R3. Wait, the image is also wrong. Let me check image on this router also. Yeah, it's layer 3. Hmm. Now start all the nodes. Okay, so first of all, let's start the configuration on routers. Okay, so we have access of the first router. First of all, give the name R1. Interface is 0 by 0. So I'm going to use here 10.1 IP address. Okay, slash is 24, and we can give here. Let me disable the routing table, or you can give the default route. Okay, so let me configure here default route. So the default route is toward ASA. So it's 10.10, the firewall IP address. Okay, as we know, show IP route. Okay, guys. So the gateway is configured here. Okay. So similar configure on R2. Host name is R2. interface is 0 by 0. What is the IP address here? We can use 10.2, okay, slash 24, and IP route uh, 10.10 again, okay, the IP gateway. And let me write down the configuration. So similar, we will start on configuration on R3. So we want to make R3 as server for TCP and UDP configuration, okay. Like we need to enable here telnet or something if we want to inspect the TCP traffic. And for UDP also we can generate some DNS traffic. So how we will do that, we will see. And here is R3, its interface and IP address 12.3, because I use network and the IP according to router number. And after that we can also give here one default route towards firewall. So firewall is here 12.10, okay. So same IP for both and LAN and WAN. The subnet is different. And now we want to enable here telnet. So as we know, inside the line VTY we can do that. Transport input all, and we can configure here password Cisco. Okay, so we have we configured here telnet configuration and password is there. So now let me do one thing. Wait a minute. The switch is still not up. Why? Okay, now switch is up. So the next configuration I can configure on firewall, so I can check all the devices are reachable to firewall. So then firewall will start the connection tables. Okay. Now, so first of all, let me give here host name. Host name is ASA. Okay. And now if you want to check show interface IP brief, so these are the interfaces. Okay. So we are using here first two interfaces, gig 0 by 0 and 0 by 1. So configure gig 0 by 0, no shutdown. If you remember guys, whenever we are going to configure an interface, we must assign the name if on the interface. So every interface must have a unique name that can't be same on each interface, okay. And according to name, we are using policy and configuration on firewall. So I'm going to use here inside. So as you remember, if you configure this word on any interface, automatically that will set the security level 100, okay. Except this word, if you configure anything else, it will give security level 0. But whatever you want to assign, so you can use this command and the range is from 0 to 100 only, okay. But inside is trusted interface inside for LAN, so that's why by default it have 100 security level on it, okay. And now I'm going to configure the gig 0 by 1 interface. So suppose we are giving here name if outside. So now you can see outside have security level 0. So security level 0 means this is last trustworthy interface on firewall. Okay. And now I guess I forgot to configure IP address on other interface. But before that I will configure here. Okay. And interface gig 0 by 0 IP address 10.10 slash is 24. Okay. Cool. Show interface IP address. So command is bit different if you remember. So here we have show interface IP brief. This command. Okay, so both interface have here now IP address. And now if you try to check route, so the command is show route here. Normal router have show IP route, but we have here IP route. And now you can check whenever you have any route in routing table, so that is directly connected with interface inside or outside. Even you can see interface number is not visible here. So that's why the importance of the name is here, you can see. Okay, and now if you check, uh, we have some default policies here or default inspection. So before that, let me tell you something. Okay, so if you want to inspect any type of traffic, how you can inspect it manually? For an example, if I'm saying we want to inspect some IP traffic like ICMP, okay, by default you can't ping from LAN to WAN, okay, ICMP or you can say IP traffic is not allowed, but you want to inspect this traffic. So how we can do that? So first of all, we need to match the traffic, right? So you need to define, okay, this particular traffic I'm trying to match and I want to inspect this. So we can match the traffic inside the class map. So class map is like you can give any name. So I want to give any name. This is name. This is not the protocol. Or you can give any example like task one, okay, for me. And I can match here ICMP traffic, right? Secondly, we need to, okay, there is one thing also. We can't direct match the traffic inside class map on firewall. If you remember, on router you can do that, but this is not possible on firewall. So for that you need to create here access list, guys. What do you need to create here? Access list. Okay, you can give any name of access list, like I want to give here task name, okay, permit any and like the traffic is I don't remember, I need to check the command, ICMP or something like this, right? So this is not EQ, this is even protocol. So ICMP any like this, okay, and later on you can match here match access group. So access group means you are trying to match this access list into your class map, okay. So the group name is here, guys, task one. So this name is here, okay, so I match it with the same color. And now later on, once you match the traffic, you need to inspect this traffic, okay, inspect the traffic. So how do you inspect the traffic? So as you know, we need to create here policy map. So policy map name is also for me like, okay, it's p map for me, okay. So inside it I will move to my class map, whatever class map name is configured above. So class map name is again task one. So just make it, okay, c map for me so I can remember it. And here it is, c map, okay. And under this, once you move inside this, you can do that here, inspect this traffic. So that command you need to give, okay. So these are the two steps, and the third step is apply this one. So we can apply on global mode or on some interface. So where we can apply it, guys? We can apply it on our inside interface, okay. Apply in the service policy. So we have here one service policy. So under the service policy I am going to apply it, okay. So that is in my global mode service policy, such type of command, and service policy is my p map here, okay. So this is my p map. I need to define my interface, and interface is like inside. So that means if any traffic is coming, okay, let's come to this diagram. Now if any traffic is coming on, if any traffic is coming on this interface, okay, now this is not only going to check your connection table, routing table, this is also going to check now policy. Instead of service level policy, it will check the policy for all traffic. Okay, and in that policy, it's going to check. It have to check PMAP whenever traffic is coming from inside interface. Okay, and under the PMAP, it's going to check what I have to match. I have to inspect the CMAP traffic, which is class map C, and class map C have here one ACL, which is going to inspect ICMP data. So that how you can apply or you can manually define it. But I can do that also with my default policy. Instead of creating separate policy, I can match traffic in my default policy also. So first of all, I will show you default policy, then we will create our own policy. Guys, are you getting my points? Hello, Sankar, Daniel, Kenel, Nandita, Siva, Vicky. Guys, are you getting my points? Okay, great. If you have any doubt, please let me know, because this pattern will be remain same during the entire ASA session, not only today, because we will include multiple things with time. Okay, so this will be the remain same, just we are going to add few more steps in it. Okay, maybe NAT, PAT. Okay, like ACL or something else, but this will be the same behavior for ASA. It's going to check connection table, routing table, then NAT and ACL and all things. Okay.
Hello, sir. Sorry for interruption.
Yeah, yes, Kavya.
Sir, Vic is new today. It's his first class.
Okay, Wiki is new.
Yeah.
Yeah, just yeah, that's why I just tried to explain the basics of ASA first before starting the practical.
Yeah, yeah, yeah.
So for more clarity, uh, we will share the previous videos of the lecture so they can understand it. Okay, if they have any doubt, so I will
Yeah.
clear in next class.
Okay, okay, sure, sir.
uh,
Thank you. Now you
okay.
can. Thank you.
Vicky, are you getting my points, like, or like you are not getting anything from this lecture? Are you understanding the basic concept of ASA, like how ASA is forwarding data? You can just compare from a normal router. Router also checking the routing table and forwarding it, right? So similar, ASA also doing the same thing, just adding its own feature with it. Like normally you can send from LAN to WAN, but if you try to send data from WAN to LAN, that is not possible because this is security appliance, as we know, right? So do you have idea of, or are you getting the points? Uh, are you listening me, Vicky? Hello.
Yes, I'm listening. Yes,
Oh,
hello.
okay, okay, okay. Let me continue. Okay, so like we have not discussed much about ASA before that class. So this is our first class on ASA with traffic flow. Okay, and the command line. So command line is also like normal firewall. We have privilege mode.
Let me ask you, which software you gonna use in this class, the EV Lab or the Peanut Lab?
I'm using AVNZ. You can even use any one of them. If I'm comparing both tools, so in AVNZ, I need to stop the nodes and then I can connect the connections. If you remember, I do that already. But in Peanut Lab, you can directly connect the nodes even in the power on mode. So there is no problem. So the images and everything remain same for both. So I will help you at the end of the lecture how you can do that. Okay.
Okay.
Okay. Now, so I configured the ASA and we can check. So let me show you first. Okay, guys, is this font size good for you or do I need to change it?
Yeah, it's okay.
Okay.
Yeah,
So first of
I
all,
have one
Yeah.
doubt.
yes, please.
Which policy it will check first, global or the policy we create?
Actually, it's depend on the interface. If we applied the policy on interface, it's only going to check that policy. If there is no policy, then it will check the global policy, right? Because I want to apply policy on my interface, so it will check that policy instead of global, because global is not required to be checked at that time. It will check after that global policy if you want to check. So first is our policy which is on interface, right? Because this is the traffic flow. If you check, like what I want to do, wait a minute, I need to, okay, see. So now device is checking here SLP interface, right? Because it's security level. But if I'm going to apply here some policy, if I'm going to apply here some service policy, so it's going to check first of all interface policy. Okay. After interface policy, it's going to check global policy. So this is the sequence. Okay. Because currently
Okay.
device is checking the global policy, because there is just SLP which is just permitting the traffic from higher to lower. Then it will check the global policy to inspect the traffic. Like by default, it inspect the TCP and UDP traffic. So if you check on ASA, show run service policy. So you can check we have here one global policy, but there is one point. If you remove this policy, still ASA is going to inspect the TCP and UDP traffic. You can't stop that, right? So this global policy just show you some protocols where you can allow them or inspect them. They are already allowed like ICMP, but they are not inspected. How? So this is service policy which is applied in the global. So this is the where you can apply it, and this is name of the policy, global underscore policy. If you check class map, wait a minute, before that I will show you policy map. This is service policy. So policy map is through. Okay, now you can see. Hmm. So we can see we have here, this is our global policy, right? So global policy is carrying here one default class, okay, for inspection of traffic. So by default, this is inspecting multiple traffic like FTP traffic, okay, RSS traffic, and skew net traffic, SIP traffic, TFTP traffic. But if you can check, there is nothing like TCP or UDP. Why? Because this policy is not responsible for TCP and UDP. If you remove that, still ASA will pass the traffic. But maybe you want to inspect some ICMP traffic using this global policy. So in this policy, what I can do, I can put my traffic, or I can use inspect ICMP inside it, right? So for that we can use. So this is global policy if you check, but this is not the actual that global policy. We are talking about TCP and UDP. You can't stop that traffic. For an example, I will show you. Okay, there is show con. So this is my connection table where you can check currently there is no connection. So before that on ASA, I will try to ping all the users like 10.1. Is it able to ping? 10.2 and 12.3. Okay, so that means everyone is able to ping from ASA. And now what we can do next, No. Okay. So now I'm trying to send some data. So first of all, I will try to send some ICMP, not ICMP data, TCP data. Okay. So we want to do telnet on 12.3. So you can see we are able to open the connection and the password is Cisco. So now you have accessed the router 3 through router 1. So that means there must be some connection table, right? So we can check through con table, and in con table you can see we have here one entry. That one entry is here, and traffic is belong to TCP. You can check traffic is belong to TCP, and it's showing the traffic is going outside to IP address 12.1.1.3 and on port number 23. Okay, from which interface? It's going from inside interface with IP address 10.1.1, and this is the random port number. This is the random port number, and this is the idle timer and your bytes, and we have some flags also. We will discuss later about the flags. The flag is UIT. Okay. Okay, what is the meaning of UIT? We will discuss that also. But you are able to see the connection is built and the traffic is also receiving back. That's why this router have connection here, right? But still we don't have any TCP or UDP inspection. So again, if I will try from this router exit, and now after some time this connection table will delete the entry, because if you have connection it will maintain it during this connection. But if you drop connection on this client for server, so immediately it will flush out this entry. Okay, and now if I trying to ping 1.3, my mistake, this is firewall. So I can do one thing. We can enable, wait a minute, what is the command? Console, no, wait a minute, I forgot the command.
Logging console.
Yeah, logging console 7. Okay, so this is going to enable severity level 7, 0 to 7, and logging enable command. So these two commands will enable your logs on firewall, but in real environment you will not do that. Why? Because you enabled the logs, because real environment device generate a lots of traffic or pass a lot of traffic through it, right? So if you once enable the logs, you will lose the console, because even you will not able to put any command. It will show you thousands of logs at a time. So this is not good idea. So logs must be stored on your syslog server. Okay, so we will do that also, how to store logs on syslog, how to configure syslog. But for now, just we have enabled it to see the logs. Okay. So now what I'm trying to do, I'm moving to the R1 and trying to ping to 12.1.3. So you can see the traffic is not receiving any response. And at the same time, I will show you showcon. Wait a minute. Okay, I need to ping it again. Okay, guys. Now you can see here the ICMP traffic is coming from going on outside network. You can see the port number is visible here, 0. You can see, right? IP address and the port number. It's coming from inside network and the port number is 1 with it. But for outside it's 0. And even there is no flags with it, right? With this traffic. And if you see, there is no inspection for traffic. Why? Because they just create the entry in connection table, but when the traffic is coming back from outside interface, that means firewall just pass the inside packet. Okay, but when traffic is coming back to firewall on WAN interface, on your outside interface, okay, from 12.3, from this router to destination interface inside, so that traffic is denied. That traffic is denied, right? Why? Because the ICMP traffic is not inspected by default. Is that clear? So now how we can achieve that? The point is how we can achieve that. So what we can do, guys? So which is existing policy on firewall? Inside that policy, I will allow it. I will allow it, right? Show run policy map, because policy map is already applied, okay, in global. So I will just move into, okay, I'm moving into policy map global. Inside a policy, I have a class, a default class, which is inspecting the traffic, and now I'm inside it. But one more thing, my logs are enabled, so I need to disable them. So I put here policy and class map. Okay, after that I received the logs, so that's why its complete command is not visible. But I can do inspect. I can specify any protocol, you can see, and every type of protocol is visible here after inspect, right? If you scroll, see, okay. So now what I can do, I can use ICMP. So we inspected the ICMP traffic even, and now if you want to check, show run policy map, okay. So inside policy map, now you can see inspect ICMP is visible, right? So now logs are already enabled on firewall, and if we check show con, still there is no entry. And now let me try to ping. So now we are successfully got the traffic, right? So that means traffic is inspected this time. Connection table is only when you are sending the data, right? So the traffic is not here, so there will be no entry. So what I can do, I can increase the packet, so I can repeat it 100. Wait a minute. So I need to make it 1000 at least, okay. Now you can see ICMP traffic is here. Wait. Okay. Hmm. Come on. Just a minute. Stop it. Okay. Okay. Now you can see the ICMP traffic is coming from here and going to outside interface, and you can see this byte of data. So we have now permission. So ICMP connection is checked from this to this, right? And we are receiving the reverse traffic, right? So that how you can inspect it. So this is the one command. But here, if I am going to show you, we have service policy. So this is the global policy. So ICMP is inspecting currently because of this global policy, because of this global policy. So what if I remove this policy, guys? What if I remove this global policy? Are you getting my point? So what I'm going to do, I'm going to remove this global policy. So that means policies existing on ASA, but this is not applied in the global now. Okay, if you check show run service policy, so there is no policy. Let me disable the logs first. No logging console 7. Okay. Okay. Show service policy. So there is no policy. Show service policy will check. If you check in running configuration about service policy, even it's not visible, right? But if you check show policy map, so I will show you the policy map. Wait a minute. Show. Wait a minute. What command it's looking for here? Policy list. Let me check. Show running policy. Okay. So we can check here the running configuration. So still running configuration is here for policy, but the point is it's not applied. Okay. So inspection is also here. So this time, if anyone trying to ping 12.3, so still traffic is not passed through the. So it will pass through the ASA, but ASA will not inspect it when it will receive it, right? But even if you try to do telnet, still you are eligible to take telnet. Why? As I told you, this global policy is not going to prevent or impact the normal TCP or UDP traffic, but it can impact whatever you have allowed by yourself in this policy, like ICMP, like ICMP. Are you getting my point, guys? Everyone?
Yeah.
Okay, cool. Now, what I can do? So the second option which I have, I can create a separate policy for myself. So I don't want to inspect the ICMP traffic here. Okay. So one more point. Hmm, let me remove it first. Okay. So we can use inspect, no inspect, ICMP. Okay. So if you check, still service policy is not applied here. Okay. And you also removed the ICMP. So what I am going to do, I am going to create my access list first. Okay. Because in access list we can match it. Access list must have here name. So I'm giving here task one name. Okay. Permit IP any or what I can do, I have matched the ICMP traffic, right? Any. So you need to use here extended ACL. So this is extended ACL, guys. We will discuss about ACL after this normal packet inspection, how we can do ACL, the differences in standard and extended ACL. But for now, just remember this command, okay? So this is like normal ACL. I have not used here any IP access list like a normal iOS device. And the second thing, we can create the class map. So class map name is CMap for me. Match access list. So access list name is here task one, right? So whenever you configure the names, so make sure those are exact same. There not be space and anything. Okay. So make sure during the copy paste there will be no mistake. And policy map is PMap for me. Okay. Inside that I can use class, and class is CMap, right? And we want to inspect ICMP traffic. Okay. If you want to check show history, so this is the history what we did, right? So what we did, guys, so we created a ACL with name task one permit ICMP any, so it will permit the ICMP traffic. And after that we match this ACL inside a class map named CMap. Okay. And then we created here policy map. So inside policy map I defined the class map name, and under that I inspect the ICMP. So the next step is here, move to the service policy. Service policy name is PMAP. PMAP is actually your policy map name, guys. This is the policy map name, okay? And now you can define the interface, and interface must be inside. So what I did, I applied it in on my inside interface. So this is interface specific policy. So now this is not going to check only SLP, it will check the actual policy now, okay? If you want to check, show service policy, so you can check service policy is matched on inside interface, okay? And the name is PMAP. In policy we have class map, CMAP, and inspect the ICMP traffic, okay? So that we did, right? And now let me generate the ICMP traffic again from R1. So it will pass through ASA, and ASA will maintain the connection table. Traffic will revert from R3 to ASA, and ASA will check the connection table and forward it, right? So now exit it, ping. So we are able to ping now, right? We are able to ping this time. And if you check, it have matched how many packets, guys? 10 packets, right? So is there any doubt? Before that there was 0 packet, because connection table check both packet inside and outside. So when ASA is forwarding data from in to out, so these are the 5 packets, and when out to in, so these are also again 5 packets, so total is 10 packets. If I'm going to repeat the packet, repeat like 10, okay? And now if you check, these are the total 30, because 10 is here, and we sent 10 now from in to out and 10 from out to in, so total is 20. 20 plus 10, 30. Is that clear, guys?
Yes.
Okay, so now this is the easiest way that how you can create your own policy. But if I will remove this policy, let me remove it. Okay, so if I check, so we don't have any policy. If I again try to ping, traffic will drop. So there is one more command, the easiest way to enable the ICMP traffic. And what is that? So I can use this command, guys, in global mode, fix up protocol ICMP. So what this command will do, automatically this command will be inspect the traffic inside the global policy. And if you say global policy is not allowed or global policy is not configured, because we removed the global policy, right? If you remember last time, and after that I have not allowed it. So now you can check, using this command it will automatically applied in the global. See, if you check, before that there was no policy, but now you have here global policy. Why? Because I put this fix up command. So fix up command automatically put the ICMP packet inside the policy map, which is the global map. Check again, ICMP is here, right? Okay, so I think this is very easy. If you try, you will get my points. Everyone, so this is about ICMP. So now what we can do with telnet traffic, or how we can inspect the telnet traffic now. Like normal telnet traffic is inspected, but what I mean, So suppose I am using here two hosts this time. So I want to control that telnet connection. So at what time, at single time, how many users can take telnet connection of this server? So that's what I mean. Okay. If this is clear, we can move to the next point, guys. Just please give your acknowledgement on that. Okay.
Yes, yes.
Okay. Okay. Cool. So now let's see how we can inspect the TCP traffic also. So now we are going to inspect the TCP traffic. TCP means if I say like I have two users R1 and R2 and both are trying to take remote of my server. So yeah, both can take remote because by default telnet traffic is inspected through it. Telnet traffic is inspected, right? You can see both have now accessed the server through telnet. Now you can check both must have entry on ASA. See both devices entries are exist here, the connections. Okay. So 12.3 is the destination with port number 23. 10.1 and 10.2 both are exist here. Okay. Now I want to control, like I want to say only one device can take telnet at a time. So if one have connection, the other device can't take access. Okay. So what I need to do, I want to configure first of all access list for that. Okay. So access list name is telnet permit TCP source is any, destination as any, and after EQ means we are giving here port number. So destination port number is 23, right? So that means access list tell permitting TCP traffic from any to any with port number 23. The destination port number is guys 23. Okay. And later on we have class map. Class map is also tell for me. Okay. And I want to match access list. Access list name is tell. So this access list is matched inside the class map tell. Okay, because class map directly can't match any protocol. If you check match, it don't have options. You can check limited, like protocol is also not visible here. If you do anything after that, even you question mark, so this is not valid, right? That is the point. So after that we can create here policy map. Okay. uh, policy map name is like tell, and inside that we are going to match the class, and the class is tell. I want to inspect. Wait a minute. Inspect the. Just a minute. I need to do the question mark here. And what I want to do exact inside this. So priority set. Yeah, I want to set here. What I want to do? Set the connection. Okay. And what in the connection? So connections have multiple things. If you check, guys. So you have maximum connections, right? So maximum connections are keys to set the maximum number of all simultaneous connections that are allowed. Like at one time, how many connections you want to allow, right? So default is 0, which means unlimited connections, right? So default is 0. And even you can decrement the TTL, you can also do that. We will do later about it, okay? And we can also do here per client max. So one client can take how many connections? So I need to use some Windows client for that. I will do through that. Okay. And random sequence number. So enable disable TCP sequence number. So if any device is initiating with TCP random port number, so that also we can define. But for now, just we will try this, the default one. And what is that? Set connection to uh, connection max. I can give here 1. Okay. So that I defined, and now I need to apply it. on my inside interface. So service policy is tell interface inside. If you check now, show, okay, before that I will show you show history. Okay, so we are here now. See, wait a minute. Yeah, we defined the access list tell, we permitted the TCP traffic, we match inside the class map, and here in policy map we defined maximum connection is one at a time. Okay, and we defined on my inside interface. So that means whenever any traffic is going to hit from LAN to this interface, so that is going to check my policy which I defined here for TCP traffic. Okay, and now I need to remove that my mistake, and even from R2. Okay, and if we check on ESA, is there any connections? So right now there is no connection in connection table. And now let me generate connection Cisco. So R1 eligible to access, right? R2. So R2 is trying to access right now, but still there is nothing. So if you check on, so one connection is done by R1, right? One connection is done here. So let me do one thing. Logging enable, logging console 7. So we can see the logs. And now let me try again on R2, not on R1. Okay, R2 is trying connection. So now you can see the connection limited exceed 1 by 1 for interface packet, input packet from 10.1.2 on this port number to 12.3 on port number 23 on which interface, guys? Inside interface. So that means 10.2 is trying to take telnet connection, but ASA is limited that, right? So that how we can control or we can inspect the traffic here. Is that clear to everyone, guys? So on ASA we can check show service policy interface inside, right? So on interface inside we have current connection is 1. You can check, right? Because max connection is configured 1, and it drops the 8 connections which is initiated by your 10.2 PC. Is that clear, guys?
Yeah, can you show the commands once again?
Okay, so let me show you. Show history. So the first step, always create a access list. Okay, so these are the commands. Okay, create the access list and match this access list in the class map, and later on class map must configured inside the policy, and here you can inspect and you can limit the connections. And the third step, you need to apply this policy map in service policy.
Okay.
Okay,
Yeah.
so I hope this is clear to everyone, guys. If TCP inspection is clear, we can move with UDP inspection now. But if this is clear, then we can move. Is that clear to everyone?
Yep.
Okay. Okay, guys, great. So how we can do UDP traffic? So as we know, normal DNS is belong to UDP, right? So we can initiate here some UDP traffic. How we can do that in this case? So it's very simple. We can configure R3 as my DNS server, and I will resolve some domain name from R1. So it will send DNS request to R3, right? So that DNS request is UDP, which is inspected by the ASA. So that we can do. And on R3, I will move here, and what I can do, I can configure IP domain lookup. Okay, IP name server is okay. Here we no need to define the name server because this is the device. IP host, we need to configure here domain name like cisco.com with my IP address. Okay, so that means now R3 is the DNS server. Show DNS. Wait, yeah, show. Wait a minute. What is the command? Show DNS view or something like this. I forgot the command. There is some command to check the DNS. This is as DNS server or no, or is it show name server? Show IP DNS view. Okay, yeah, this is the command. So domain name is enabled here. If you check, right, here is the domain name, right? So domain name is enabled, and we have created here one entry. So that entry says if anyone is trying to look up, take 1 minute, it's not, it's host only. Okay, so that means now R3 is cisco.com server for me. Okay, and R3 is going to resolve that. So what I want to do, I will configure same thing on R1. So if R1 want to resolve anything, okay, so it must know who is the server. So IP name server is 12.3 for me, right? Okay, so now what I am trying to do, I'm going to ping cisco.com. So it's translating, and the domain is here 12.3. Wait a minute. Okay, it's no, but wait. The protocol is not running. IP domain lookup. So it have to look up. Wait a minute. Just a minute. Maybe I'm doing something wrong. Okay, yeah, maybe one command is missing to make server to R3. Yeah, so this is now DNS server, I guess. Let me try again. Yeah, you can see now it's able to ping. So what command I did on R3? I configured one this command IP host. So host is 12.3 with name cisco.com, and it's now my DNS server with this command IP DNS, and one command is IP domain lookup. Okay, which is only required here. On R1 that command is not required, which I configured lastly on R1. So now I'm giving here another name that maybe will not resolve, but it will generate the UDP traffic for me. Okay, and now I can see here one entry show. Wait a minute, show con. So you can check the UDP entry is generated right this time. So with port number 53 as destination generated by 10.1. Okay, so that how it will inspect this traffic also, because UDP traffic is very quick. If I do cisco.com, that will not visible for me. Why? Because it will just resolve it and entry will be removed right immediately. So I just requested a random URL which is not existing, so it will not receive any DNS response packet, right? But that time we can see the entry only. Okay, so is that clear, guys? So the configuration is very simple. Okay, so that how you can check. If I do cisco.com, and if you check now, entry will be not visible. Okay, maybe it's here. Yeah. Okay, so that how you can check how ASA is inspecting that TCP, UDP, and ICMP traffic. So we have just seen the traffic inspection today. So till now, if you have any doubt, just let me know, guys. Because in next class, I am going to discuss about the ACL configuration, ACL types on ASA. So if this is clear, then you will understand the ACL, and it will add one more point in our traffic flow on ASA. Because if I use ACL, then it will change the behavior of SLP. So is it clear? Vicky, Nandita, okay. Kenil,
Yes, yes.
okay. Uh, Danny, Sankur,
Yeah, it's okay. It's okay.
oh, okay, great guys. So I think that is enough for today, because few of candidates are new, so they can go through with the video, okay, later on. So if now guys, you can tell me if any one of you have doubt in installation of virtual lab on laptop. So normal ASA practical you can do on laptop if you have 16 GB RAM and i7 i5. So I can help you now if you want to.
Yeah, I'm facing issue in ASA image. I share
Oh,
the snapshot also in the.
okay, could you share your screen, uh,
Okay,
Vicky,
let me.
so I can see. Guys, if any one of you want to drop, you can drop. Right now, we are just checking the lab installation. If you want to stay here, you can stay.
Sir, I didn't get any notes or any mail from you.
Okay, team will share one link in group today. Okay, because I will upload all the videos on that drive. So everyone will get that drive access. So you can download the notes and videos from here, and even the PDF book for course.
Okay.
So I will upload tonight. Okay, till morning you will get the link. So you can go through with the videos and notes.
Okay.
Okay.
Thank you.
Okay, I share my screen.
Okay.